Welcome to another Tech Night. Tonight's Tech Night, is on ignition systems, and we're going to start off with the two original ignition systems, and that is the magneto ignition system and also the battery ignition system. So on my old 26 Dodge, it has the magneto system. And of course, on my next vehicle, the 37 Dodge, I've got a normal ignition system. So these two have two very common parts. And the two common parts is a magnetic field. So just going over the components of the actual magneto system. Of course, we produce the magnetic field from having a magnet over the top and an armature through the center. And of course, we have our north and south poles. And as that is spinning around, as long as we've got the points closed, we're going to be building up a magnetic field. Of course, when the points are open, the magnetic field collapses. And then, of course, the spark comes through and goes to the center point where there's a rotor button, and then it distributes it around to each cylinder of the vehicle. Of course, on the other picture, we've got our basic ignition system, which of course we've got the battery there, we've got the ignition coil, we've got the set of points, we've got the distributor shaft, which is run off camshaft time. We have the condenser and also in parallel a condenser or capacitor. Also, that is the top of the distributor there where we have the rotor button and also going out to each spark plug. So the two systems are very common. One's run off battery ignition, producing a magnetic field. And of course, on the other side, we have the magneto, which is producing its magnetic field from rotation of a shaft with magnets. Okay. So we're going to concentrate now on the basic ignition system. Of course, we must have a battery in the system. We must have an ignition key. We must have the ignition coil. One side is the power side going into it. The other side is the power going through to the ignition points. And of course, as I said before, the condenser is wired in parallel to the points, which we'll see that in further pictures. And then, of course, we have our spark plugs. Now, on the ignition coil, we have two systems. And that, of course, is the primary and the secondary. Of course, our battery ignition key, one part of the coil and to the points of the condenser is called our primary circuit. And of course, when we have our high voltage coming from the ignition coil, going from our coil to our rotor button and then distributed out in the firing order of the system. Of course, this is a better picture of the primary. The primary is still in green with our condenser, the ignition points, and our secondary with our rotor button and to our different points of our distributor. This is a 4-cylinder because it's got 4 notches, and the 5th one, of course, is coming from our ignition coil. So coil construction, as you can see, we can see the primary winding on this side of the coil. It runs around the coil. It's quite a thick wire inside the coil. And then, of course, it follows its way out to the ignition points and the condenser. The very finely wound coil, which is around a soft iron core, and there's a ratio between these. And of course, we'll go over what actually happens very shortly. So ignition capacity depends on three factors: on the turns ratio, as I said before, between the primary windings and the secondary windings, the force of the magnetic field established. So the bigger we can make that magnetic field, the better off we are, and the speed that the magnetic field coil can collapse and re-establish and back and forwards gives us our beautiful spark. But in the early days, we certainly didn't have a brilliant spark compared to late model cars of today. So looking at the circuit of the ignition system, of course, I've got my battery. It goes to my ignition switch. It then goes to, normally there's a 15 on the side of the coil. On most European vehicles go by these numbers. 15 is ignition power. Of course, we've got our windings going around, which are our primary windings, which are the thick windings. And of course, they're going off to the ignition points. And of course, our condenser in parallel. Whatever happens on this side, it will be, it will happen on this side also. So this is the ideal of it being in parallel. But we'll go over why we've got a condenser in a ignition systems. There's two reasons. But at this stage, you can see when the points are closed, we are building up the magnetic field. So when the points open, we've just had them closed and they've just opened, of course, by the cam here, which is hooked up to the camshaft timing. So it's in relationship to the 4 cycles of the Otto engine. And of course, as soon as we open up the points, the power is taken away from the primary windings. They collapse over the soft iron core into the secondary windings. And of course, guys, we have a magnetic field that collapses. And of course, it induces a spark going out to the spark plugs of the engine and distributed around to each cylinder. Of course, on this, we've talked about building up the magnetic field collapsing. So at this stage, we're going to start talking about the condenser. So with this situation of the power having a disruption, and of course, we've built up quite a lot of amperage through here. It runs about 4 amps, a normal ignition system in these early days. And of course, we have a problem where the ignition points, the amperage wants to jump across. And of course, we need a device to have a straightaway cut off. As soon as the points open, we stop the power going across and we stop the situation of it trying to get across. So of course they have a condenser, which this suppresses the voltage and amperage. And of course, we don't have the situation. If we didn't have a condenser there, guys, it would have a situation of the points being burnt very quickly, and also the points would overheat and they'd turn out to be a electric blue color. And this is overheating of the points. So if a condenser's on its way out, you will get burning of the points and you will see them in a blue color. So that is one thing what the condenser does. It suppresses. But on the other side, before the points close again, the condenser starts, some of the charge goes to earth and the other part of the charge goes back to start building up the magnetic field of the coil before the points are closed. So it's getting it up and running, which is very important because depending on the number of cylinders what we've got, If we've got a 8-cylinder or 12-cylinder, whatever, we've only got a small period of time to build up that magnetic field. So the 4-cylinder engine is the one that's better off in these circumstances, and it just gets worse and worse for the 12-cylinder or whatever size larger engine. So here is the condenser, just some more pictures, and I have answered the question of why we have a condenser, but this is just showing the arcing that will happen if we don't have a condenser, where with a condenser it's just a nice clean situation and the points have a better lifespan of their life. So our primary circuit, guys, with the magnetic field, we have a 12-volt system using the coils around the 3 ohms, and of course we have 4 amps in the circuit. Our ignition systems of the early days couldn't have anything more than that, because otherwise it was too much strain on the system, and which I'll show you later what we do to improve situations, especially when we're starting, because this amperage will change and the voltage will change when we're cranking an engine over. We won't have the 12 volts what we normally have, but we're going to put them in more realistic figures very shortly. So just looking at a graph here where our ignition coil has got 3.4 ohms, which when we talked about electrical last time with wiring a pair, we went through ohms and amps and volts, but ohms is the resistance. And of course, the primary current while starting, of course, our starter motor jumps down to about 10 volts. We've still got the resistance of 3.4 ohms. And of course, we're going to have 2.9 amps, which is going to reduce the spark of the engine. And where do we want the spark? We want the spark when we're starting to get that engine started. So dropping it down to 2.9 isn't the best situation. And sometimes the older cars struggle, especially when it's very cold, to get started, because we're just putting more. Imagine when the starter motor drops down to 8 or 9 volts, it just gets worse and worse. And of course, when we're driving down the road, gentlemen, we have our primary current while driving, our generators happening or our alternators happening. We're getting 14 volts. We have our 3.4 ohms resistance. And of course, we have 4.1 amps happening at the points, which is our maximum, what we can put through the points. Replacing the ignition points is a very critical thing. We buy our set of ignition points, and of course they come in a packet, or they just come loose. And my suggestion is that you use a little bit of thinner, something to take the plastic coating off, especially the base and off the point contact of the points. Because what happens is you start the engine, it runs a little while, and then it starts burning the plastic away, and then it has no contact across the points. So it's critical, guys, to use a little bit of white thinner to clean that plastic coating off that's put on there for so the points won't rust up. And of course, the other thing that I'm putting across there is where the black arrow is a little bit of points grease. Now, over the years, I've when I was training people in the workshop, and we did have points in vehicles, we put on a Bosch points grease. If we use wheel bearing grease is very interesting, because when you see it in the tin, it's nice and thick and what have you. You drive a car around for a while, jamming on the brakes and heating up the grease in the front wheel bearings. And then if you take that cap off, I can assure you that the grease that's in there is going to come flying out at you and probably burn you, because it goes to a liquid form. So that is the last thing what we want on ignition points. And going back many years ago, the person is now deceased, so I won't say their name, they decided to use wheel bearing grease for lubricating the points. And of course, we're on a rally and he was behind me and I could hear this engine backfiring and carrying on. Anyway, he pulled over and I pulled over too. And I said, oh, what sort of work have you done to the car? He said, oh, I replaced the points. And of course, we took off his distributor cap. And of course, there was grease everywhere inside the distributor cap, which was causing misfires and what have you. Cleaned off the grease and she was right again. But you do need to have some lubrication here, and that's where it's important that you get the bush grease. And of course, when you buy some ignition points, they do come with a little satchel of the special grease anyway. Moving on to adjusting the ignition points, of course, most people will use the old feeler strips. But using feeler strips for a brand new set of points is fine. But it's a little bit hard to get them exactly right. And it's probably an old school situation where you use those. The proper way of doing it is setting it up with a dwell angle meter. And of course, the dwell angle is the amount of degrees the points are closed. And that's the figure what you get. And that's what you adjust it up to. And of course, it's virtually the same as the point gap. If the points are going to open up to that gap, but you've got a meter that you can adjust it to. And of course, you can check the dwell on the engine, because at some stages, you might get a little bit of wear on the little peg where you've greased. So it's worthwhile just to check the dwell angle. Of course, if the dwell angle changes, your timing will change. And of course, large gap, inefficient dwell, small gap, excessive dwell. So you can see when you put the meter on which way it goes.
So Bruce, when you're referring to a dwell angle meter, it's an electronic meter, isn't it?
Yes, yeah, it's an electrical meter. Yeah. Probably not electronic. It's more, electrical. And for the older mechanics, we had these meters. Sometimes they can be called a cam angle meter. My father's old equipment, it classifies it as a cam angle meter. And of course, on the older car, sometimes it is known as cam angle meter, cam angle that you're adjusting. So what we're going to do here, guys, is we're going to have a small question time on all the information we've gone over so far. So I'll ask, is there any questions? Anything that we need to re-go over because you're confused about, or you've got questions on something? Remember, you will have to unmute yourself. I'll take that everybody's understood what I've said. So we'll continue on. Okay, so ballast resistor ignition system. This is slightly different. This is to enable the engine under starting characteristics to have a higher amperage. So we try and get it up to around the 4 amps on starting when the starter motor is going down to 10 volts. So this system has got some different parts that are on this system you cannot use on the earlier system. And firstly, the first thing that we have to change is the ignition coil. The ignition coil has got a different amperage compared to our 3.4 amperage coil that we had in the past. You'll also see that there is a resistance on our circuit line going from our ignition switch, which says resistance. This resistance can be of a wire nature or can be of a nature of a actual piece of insulated material with the wire running through it. And it is wired up slightly different because when you're actually turning over the engine, the power that you're getting from tripping the starter motor over, which is 16, comes to the ignition coil first. It takes the easiest path, and of course we're getting that power for building up our magnetic field. So ballast resistance, as we saw in the past, we had a 3.4 ohm, which is our standard coil, and we only had 2.9 amps across the actual points, and of course running we didn't have a problem. So what we've done is we've changed the ignition coil to a 2.4 amp, which they normally have a note on the side. This is a resistance coil, and you'd have to look at the amperage of it to determine what it is, because you just can't, on a lot of ballast resistance ignition systems, they can change from car to car what ohm coil they're going to use, which I'm going to show you in another document coming up. So our ballast resistance or series resistance is 1 ohm. And of course, on cranking, we have 10 volts. And of course, we're going to just have the resistance of the actual coil, which is 2.4. So on starting now, guys, we've got 4.1 amps, which is our full capacity, what we can run across the points. And that should be giving us a nice, easy start. And of course, when we're running down the road, the two resistances are added together, and we have our 3.4, so we have 4.1 amps. So you can play around with the resistances and even make a better situation. You can see in this situation that we've changed the coil to a 1.6 ohm coil. Our ballast resistance we've put to 1.8. Of course, on cranking, we've got our 10 volts and we've got our 1.6. So we have 6.2 amps. Now, somebody's going to say that is too much amperage for the points. This is only for a short amount of time. And of course, if we start the car quickly, and we've got a bigger spark, well, this is going to make the whole situation a lot better, because we're not going to be cranking to get the engine started. And of course, when we're driving down the road, 14 volts from our generator or alternator, and of course our resistance of 3.4 and our 4.1 amps, where we're using the system the most. So we're going to move on to the next part, and that is advanced systems on the engines, because we want some sort of acceleration on our engine. A lot of our real old engines weren't very quick off the mark, and this was caused because our timing devices weren't up to scratch. Some of the timing situations were done with levers on the steering column and so forth, and you had to listen to the engine to get the best out of the engine. But later on, we didn't have that situation. We had other devices which helped that situation come along. So we run to our auto cycle, and of course, guys, on our auto cycle, we have our first stroke, which is our induction or intake stroke, or as what we say, suck. And then, of course, it's squeeze, bang, blow. That's one way of remembering it easily if you get caught up with your words. But that's always in the back of my mind, because that's the slang way that I learned. But of course, we've got intake stroke. And of course, on intake stroke, guys, the piston is going down. When it's going down, the intake valve, which is on the left-hand side of this picture, and what we're doing is we're drawing in our air and fuel ratio into the combustion chamber. And of course, the piston goes down, and at some stage we get to the bottom of the stroke, and we're closing the intake valve off. We then go on to the compression stroke, where we're compressing the air-fuel ratio. Remember, this is in an atomized state, and we're warming it up to a certain degree. And of course, that is our compression stroke. Then when the piston gets to the top of the stroke, and we've compressed the air and fuel ratio, we've got both valves closed, of course, same as when we've got the compression stroke. And then, of course, what we do is our ignition system sends through a spark at the right time. And of course, we have an explosion, which will then send down the piston. And of course, when it gets down near the bottom, we go to our exhaust stroke, where the piston is coming back up again, and we open up the exhaust valves, and of course we push out any of the unburnt gases and so forth out the exhaust system. So that is basically our Otto cycle. We're going to talk about it in a little bit more detail coming up in the next couple of slides. So piston position, we have before top dead center, and after top dead center, which is important that we understand these three positions when we're talking about ignition timing. So actual valve timing diagram for a four-stroke engine. So on this diagram, you can see what I was telling you before isn't totally correct. This is getting into more tuning the engine and developing more power out of the engine. And of course here you can see that IVO represents the intake valve opening. So it's opening before top dead center. And of course the piston is going down, and it keeps on going down. And we want to keep this going as long as we can, because we want to get in as much air fuel ratio into the cylinder as possible. And as you can see here, guys, 30 degrees after bottom dead center, we are closing the intake valve. We would then move on to our compression stroke, where our compression stroke, we start compressing and compressing. And this is where it becomes different, because when do we want to make the explosion happen? Now, this depends on a lot of things. And the main thing it depends on is what sort of fuel are we burning? How fast does that fuel take to explode? So it might be a few degrees before top dead center, the fuel explodes, and then when it gets to top dead center, it has the full push of the piston going downwards. On a diesel engine, because of the different flash point of the fuel, you'd be probably talking about 30 degrees before top dead center when we'd inject the distillate into the combustion chamber. So you can see the difference depending on what quality fuel you are using is when we would set up the timing. And maybe on our older cars, the timing that they set many years ago and the types of fuel that they had then is totally different to our fuels of today. Years ago, I visited the Mercedes-Benz factory in the engine development spot, and they are really critical on having their ignition systems correct and what have you. And they had samples of fuel all around the world in these different bowsers. And of course, they'd be setting up their ignition timing for each different country because it varied, because there were so many different grades of fuel around the country, around the world, I should say. Of course, then we have our power stroke, and of course the power stroke pushes the piston down where we get the power to turn the transmission, the tail shaft and the wheels. And of course we then finish up when we think, or we're close enough, we've virtually burnt all the fuel and there's no power loss. As soon as that happens, we then open up the exhaust, and of course the exhaust valve opens, and that is before bottom dead center and goes right up to after top dead center, because at this top here is valve overlap, and this is where we're actually cleaning the cylinder out of the last of the exhaust. Of course, guys, setting up your ignition timing to the camshaft and crankshaft, as I said before, the ignition timing is running at the same speed as the camshaft, and you can see the gears of the camshaft, which is an overhead camshaft, and also our other camshaft, that is other gear that is running our distributor. And you can see here that this should be virtually a 2-to-1 ratio. So the crank gear has to turn around twice to one turn of the camshaft. Of course, another picture here of just setting up the timing with a timing light. So, mechanical advanced systems. So, as the engine goes faster, guys, what has to happen? And that is the timing has to become earlier and earlier. Otherwise, we're going to be running with the explosion happening on the power stroke. When the piston is not at the top, it's partially down, and this would be known as retarded timing. So we have to advance. So this advanced system, you start spinning the shaft, and of course these advanced weights fling out and they turn the top part of the shaft to a more advanced time. Now, it's very interesting with these distributors. A lot of people decide that they're going to restore a distributor, and this is a very ticklish situation because you've got two springs here, two springs with different tensions. So you have to make sure that if you do take these springs off, you put them back on the right side. Otherwise, your ignition time is not going to be real good. My suggestion is, when you are going to do up your distributor, you need to take it to a distributor specialist, and of course he'll look up in his book of the numbers that are on the distributor, and he'll spin up the distributor and reset up these springs, because let's face it, all springs in life lose their tension after a certain amount of time, and you won't be getting the full performance out of the engine that you'd like. So that is our mechanical advance. A lot of older engines, even my 26 Dodge has a similar thing like this. So as the engine RPMs increase, they will advance the timing, and your engine will run smoothly throughout the range. So mechanical advance on the distributor of 20 degrees means that the crank is 40 degrees. So just a little bit of information: when we move it 20 degrees here, we've actually moved it on the crank 40 degrees because of our ratio of our camshaft gear and also our crank gear. So vacuum advance timing. As I said, a lot of the older cars didn't have these first off. They just had the mechanical weights. This is a system where we've got a vacuum line with the butterfly completely closed. It's on top of the butterfly. So when the car's idling, we're virtually not using this vacuum advance unit. And of course, when we open up the butterfly, vacuum is drawn here, which then pulls across the base plate of the distributor and changes the point where the actual points will be opening. So it will be a lot earlier. And of course here, the picture on the other side here is just a little bit nicer, showing you the cam plate where the points sit on and how it's working and how the diaphragm is operating inside. But vacuum advance helps us a lot in a lot of ways for that nice takeoff of the car. So the advance unit itself, diaphragm inside, this diaphragm usually perishes on an older vehicle. Of course, it has a spring inside. The vacuum advance unit is set up entirely for a certain engine of specification. So it's not wise to grab one off one car and put it onto the other and think you're going to have it all happen correctly for you. It must be the one suited for that car and that model distributor to work correctly. So, as I said before, just as the throttle opens, light engine loads, engine can tolerate more timing advance under light load, which improves efficiency and fuel economy. So it's a lot of cases, 40 degrees advance is the normal thing. And just moving on to the next subject now, this is a diaphragm, and this is Tony Villela's favorite questions in life. And that's all about the next part of the presentation. You can see here that this vacuum advance has got the one going to the top, and that's the one that we've been talking about. But Tony likes to know all about why we have a vacuum line on this side of the distributor. So let's have a look. Why we have vacuum retard. So guys, this only happened when we started to get into anti-pollution reasons. At this stage, in the old days of our cars of the 50s and 60s and what have you, and probably the 70s, until the end of the 70s, where we decided that let's really get this fuel burning. And of course, this was a big mistake, because when we have extremely high temperatures in the combustion chamber, it produces nitrous oxide, NOx. And of course, this is no good. So their first parts of trying to destroy NOx was that let's retard the engine at idle and now give it another 5 degrees, which we're going to have 45 degrees of advance rather than a normal 40 degrees of advance. Because remember, we want to make the combustion controlled so we do not produce these high oxygen or NOx in the combustion chamber. And as you can see here, guys, it's on the bottom line of the butterfly, the vacuum line going there, which pushes it back to a retard position. And of course, as soon as the butterfly opens past there, it's going to be pulling this and we get a more advanced. And this was their method. These in the 70s, and even today, some engines still have the EGR valves, and of course our catalytic converter and what have you reduce NOx also. So, but they run a different system. So we're going to have another question time now. Have we got any questions? Excuse me. Okay, I'll take it that there's no questions. Everybody must be understanding what I'm saying or is totally confused. But anyway, I'm quite happy to answer some questions at the end of the presentation, which we're getting closer to that now. So transistorized ignition system. Why did we go that way? Well, we've always wanted the big spark. and we're only at 4 amps across the points. So we had to find a way where we could increase that amperage. And on some products, we got up to 20 amps across, well, not across the points, but in another way that could run through ignition coil. And of course, this was producing a really big spark. But there's always a downturn with some situations of ignition systems. And of course, the downturn of the transistorized ignition system was we had 1 coil, and of course, we were producing a massive spark. But the problem was when the engine wasn't maintained properly and we started to get excessive plug gaps, we started to make the ignition spark get even bigger. And of course, what it would do is it would start burning out the tops of rotor buttons, the caps, and so forth. And I can remember this was, as I was a technician on the floor, we were always replacing rotor buttons and ignition caps because it just burnt everything out of them. And of course, the engine would stop then. So how do we get this big spark? So we must go back to the transistor, and I'll just explain what's what on this diagram. Of course, guys, we have got our battery here, our main power, which we call 30, our ignition power, which is 15. And we come around to this side of the circuit. We've got a parallel circuit here, one coming down here and one coming down here. You can see here that there's no resistances in this line. So this is going to be our large power line. And you can see here, guys, that we have a resistance. And of course, these resistances are wired in series. So with a resistance wired in series, we're going to have reduce in voltage. So I'm going to go on to the next diagram because at this stage I need to explain how a transistor works, basically. So with a transistor, we want to have a situation where we can put through a large current at the expense of a very small voltage. And as you can see here, this really doesn't show a transistor, but it does show a tap inside. And to open this tap, we just have this little valve on the side here, which is opening it up. And that's the basic operation of a transistor. Something with a small voltage that can open up a large voltage. And the other diagram that I found, which I thought was quite good, we've got a 1 volt battery, which is opening up this part of the transistor, which can then take through a large voltage on this side. So to make the transistor work, usually we have 0.7 volts, which will open up the base. And of course, our large current and voltage can go through here and to the source where we want it to go. So in the early days, I'll just go back to the previous picture of the transistorized ignition system. You can see here, guys, that we have a set of points here. So we're having very minimal voltage going across these points. These points will never wear out. And of course, they don't need a condenser on there to stop that arcing across the points, because it just doesn't happen with something like 0.7 of a volt. And then we've got this other resistance here, which is reducing the resistance because the base is opened up by 0.7. So this voltage here would be probably less. It could be down to 0.1, which as you can see, the points were never out. But on this side here, guys, we could have 12 volts with 20 amps coming down here without any worries, reducing our humongous spark and so forth. So they did away with the having the ignition points there, something for people to tamper with and play with. So they devised a part there that just had a rotor, and it had a magnetic field across here, and every time it went past it, it knew there was a cylinder there. So these were the later types of devices rather than having the ignition points. Okay, so guys, that is the end of the presentation. So we'll open up for an open forum now for any questions. I will say at this stage that there will not be a tech night for December, and we'll be starting in February next year. We're hoping to do some garage crawls, but the next one that we've got coming up, we've already had somebody request something, and they want to know how SU carburetors work. So that will be the next one that will happen, depending if we have garage crawls or what's going to happen. Okay, let's have our open forum.
Well, if I pose the first question, I'm aware that there are problems with the electronic ignition on the Valiants
Yep.
of around about 1980, I think, where they were introducing
Valiants.
those.
Yep.
What was the problem? What was the cause of those sorts of problems?
Well, a lot of times it was the device that was picking up in the distributor of the actual sensing of the points. There was problems with those. I've never worked on a CM Valiant to diagnose virtually a problem with that, but I know that in a lot of cases the transistor box used to blow up for some reason. Yeah, maybe some of the people that had one of those cars or mechanics that worked on the cars might be better, but I don't know the true answer to that, Mark, to tell you the truth. But I know that they did have problems with the transistors in them giving the ghost up. Maybe they weren't the right rating transistor in them. Don't know.
My understanding was the only on the 8 cylinders, and when they're running high revs, the switch rate for the transistors were producing too much heat. So they got high revs and high cylinders.
Ah, right. Okay. Fair enough. Yep. I did know of my brother-in-law used to run taxis. He had 6 cylinders and he was still having the problem, something in the ignition system with them too, giving up.
The ballast resistors also did fail from time to time as well.
Yeah.
Wire type.
Any more questions?
I haven't got a question. I've got an experience I had. Took the Dodge to, I was going to Forbes for the 100 years of Dodge rally.
Yep.
And the distributor shit itself in out of Wagga.
Yep.
They towed it back to a dealership, which from memory was Mercedes, Holden, and Hyundai or something.
Yep.
And they had looked. Said come in the morning, so I got there and the guy said the 3 service managers had a look, and the best they could come up with was a guy who died 3 years ago, and their recommendation was contact RACV and send it home in a truck. I got great mileage coming home.
Yeah, so that was in your 34.
Yeah.
Yep. So did it break the shaft or?
No, it's something to do inside. I think the some of the windings or something. It was shorting. It was intermittent. I took it over and had it rebuilt. But when I got it home, I had it rebuilt over at Auto Surplus. But after that, never confident, so I went to electronic ignition.
Yep.
Really good stuff.
Yeah, I still run all the original coils, points, and condensers because I just love that sort of thing. And the only time I've had a problem with a ignition system is that when I bought a brand new wiring harness for my 37, the man built the harness for 12 volt where I asked him to build it for 6 volt. And of course, when it was cold, it was fine. And when it got hot, it stopped. I put a wire parallel to that. And of course, beautiful. But the answer is getting the distributors rebuilt and definitely getting those advanced springs correctly set up. Otherwise, the engine won't perform. Any more questions?
Just a comment. I have previously had a lot of success with J-car transistor assisted ignition, where the points only switch the transistor and the transistor switches the load, and you can 10 years out of a set of points by just adjust the rubbing block once a year. As the rubbing block wears, the points never wore until the spring fatigued and broke.
Yeah, because the base is only putting, well, most transistors, the base is roughly about 0.7, well, 0.7 of a volt, So that's why you're getting the good life out of it. There was a lot of people, I had a brother-in-law that he was electronic guru, and he built for his FC Holden a transistorized ignition system, which lasted and it was really good. So,
No. Amazing how many people you hear say, get out with the timing, like they've got to adjust the timing. Well, there's only one thing that changes the timing. Either your cam gears are stuffed and you change stuff, or the points need adjusting, not the timing. You shouldn't have to
that's right. That's exactly right.
The points and the timing will fix itself.
Yeah, well, my motto was when I was a mechanic on the floor that, of course, you took the plugs out, you gapped them or you replaced them, one of the two, and you gave them a clean. And then you checked the points. A lot of times we took the points out because sometimes you got a little bit of oil on the bottom of the points and they wouldn't earth properly. Clean up the contacts or replace the points, as I said before. And then, of course, you do your timing, idle speed and mixture. And that was the way of doing things. But mechanics of today have got no idea how to do any of that stuff now. And really speaking, with ignition systems and fuel systems, we don't have the problems like we used to have of cold starting or anything like that. It's one of those things that's virtually perfect now. And we're not going to make any money out of those systems.
Yeah, with the, can you hear me?
Yes, Warren, how you going?
G'day. I had a D-series Ford that someone had fitted a 302 VA2, and that had a resistor in it. Bloody thing would never start when it got really hot. So I ended up simply running a 12 volt wire directly to the coil via a toggle switch. It was magic. You know, you could be kicking it over, it wouldn't start. You just hit the toggle switch, bang, away it'd go. So any comment on, I mean, is that naughty in any way to do that? Or, I mean,
well,
for a few seconds to start it.
Yeah, well, that would be fine probably. But if you're doing a service on it and or you're having problems with it and you're looking at the points and they're going blue, well, obviously you'd put too much current across the points. But for a short amount of time, and that's why some people play with ballast resistor systems to change round, as long as it comes up to 4.1 at the end for running down the road or starting is fine, because we did have an instance there where in the diagram they showed 6.2 amps, which it would be a nice system for starting when it was cold. But usually most cars were built correctly. As long as everything's in the right specification, you shouldn't be having problems. But yeah, so that was in a Ford Windsor, you said, and
yeah, 302 that they'd fitted instead of the original 6-cylinder in a D series Ford.
Yeah, so how did they have the ballast resistor wired up originally?
Probably permanently.
Yeah, that's what I'm thinking. And then when it got
bypass in the key system.
Yeah. Well, if you run the wrong ignition switch, I had a EK Holden, and I changed the system over to a 179 HP motor in it, and of course that had a ballast resistance ignition system, and of course you couldn't run the original EK ignition switch. You had to go to the EH one, which had the ballast resistor wiring for it.
ST2
So,
pin or whatever it is.
yeah, exactly.
Yeah, I'd say that's what they've probably done wrong then.
Yeah, they didn't know what they were doing, in other words.
Yeah.
Yeah, but your answer of putting a bypassing it and having a toggle switch just on starting, you're doing the right thing, I believe, Warren.
Yeah. The other thing too, you said that your timing was done on a 2-to-1 ratio with your crankshaft to your timing.
Yep.
I was reading or seeing somewhere there, one of the vehicles doesn't. It's a 1-to-1, and of course, as far as I'm concerned, that would be quite okay because on a lawnmower 4-stroke engine.
Oh yeah, they're 1-to-1. You only got one cylinder. Yeah.
Yeah, because it simply fires at the and does nothing at at the exhausting and inlet overlapping stage.
Yeah, a lot of engines probably 20 years ago, they had a double spark, one on compression and one on the opposite side of that.
Yeah.
So, yeah. Or they'd use that spark for another cylinder. Yes, Frank?
Can you elaborate on the ignition switch difference for me?
The ignition switch difference for a ballast to a normal?
Yeah.
Okay, so what I'll do, Frank, is I'll go back.
Sorry, I missed the start of the presentation.
Oh, yeah, no, that's no worries. We'll just go through to the ballast. I'm going the wrong way here. Okay, so on this diagram here, Frank, we have the ballast resistance ignition system. And the way that it works is that when you're cranking over, the wire that's going to your starter motor device to make it start, not your large big wire from the battery, but your other smaller one that hits the solenoid.
Yep.
What they're doing is they're using that power source going to the coil on startup. And as soon as you let go of the key, you've got normal power coming through through the ballast resistance. So that's where it makes the difference of, and if we go through to the diagram here, we have 2.4 ohms at the coil. On the ballast resistance, we have 1. So when we're starting, we're only using 2.4 ohms, which is giving us 4.1 amps, which is giving us more spark on the initial start.
Can't understand how that relates to the ignition switch being different because you'd need to put that exciter wire anyway.
Yeah, because what it's doing is you've got 2 tracks. You've on one track of the ignition switch, you've got the cranking side, and then you've got the spot where it's the running side. So on a car that doesn't have a ballast resistance, we only have 1 wire here. And that's why you need that extra part on the ignition switch to make that happen.
Fair enough.
That's the difference of them. Okay, any other questions?
I was going to mention something a bit odd that I came across in the past.
Yep.
I'm sort of a bit of a traditionalist. I like points and original carbies and all this sort of business, which people always argue and carry on. And
You're on the right track.
Well, I mean, Martin Hubbard and I, we can't even talk about it to each other because he argues that all this modern stuff's all the go, and yet he complains how long he spends fixing all this stuff and then he can't do it. And I said, Martin, I've owned cars for 30 years. I own probably 100 cars. I'm not a technical bloke like, say, you are with all this stuff, but I work on common sense. So hence why I leave everything original. But getting to the actual point, excuse the pun with point, but anyway, points.
Yep.
on that 57 Chrysler you see in the background of my screen,
Yep.
the car was running great, and I just thought, I'll just check the points and all those things one day and see how everything is. And took the distributor cap off, and the rotor had been running a bit sideways, like running a track in the distributor cap, which looked a bit odd, like something was a bit bent or whatever, or the cap was made a bit off or something. So I thought, I'll put a new cap on it, which I had new old stock on here. The car wouldn't start. So I thought, what the hell's going on here? And it turns out new old stock cap's been put back in the old box, and it doesn't have the spring at the top and the plunger. And I thought, anyway, so I went and put the original one back on. Car wouldn't start, and I thought, oh no! I thought this is Christine here. This is going to happen. So in the end, I thought, what's going on here? I ended up replacing the points. I ended up doing everything, and the car still wouldn't start. I'd never come across this in my life. I thought, stuff this. I was able to find a couple of years ago. I found a new old stock, a complete correct numbered distributor for a 392 Hemi. I couldn't believe it, but I thought, stuff it, I'm going to put that in. And I put that in, the car still wouldn't start. I thought, what's going on here? This is like, I feel like I've never worked on a car ever before. Anyway, I rang up a mate of mine, Terry McMahon. He's been in the cars forever, and he's actually an electrician by trade, but he's one of the first people who bought cars in and blah, blah, blah. Anyway, I rang up and said, Terry, this damn thing won't start. I went through the whole story, and he goes, he says, you paint cars and that. He goes, go and get a bit of thinners and wipe between the points. I said, what are you talking about? And he said, before 1960 something, they used to put, this crap between the points on all these things. And he goes, go and wipe between them and clean it and come back and tell me if the car starts. And I rang back and said, you bastard. I've been working on this all day, and that's all it was. And I found out since it's happened to me again, I've actually used, I try and buy like old stock stuff, and those old points had a
plastic coating over them. It was quite normal for sometimes the cars would start and they'd run for 5-10 minutes and then they'd stop, because at that stage it sort of frizzled up all the plastic coating on the points and then they'd stop. But I was always taught, get some white thinners and wash the points first and then put them in. And that always made sure that there was no plastic coating left on them. So
it's just one of those things. It's one of those things I mentioned to a few people who've been mechanics for decades, and they go, I've never come across it. And it's just one of those things that it's worth noting, because it's one of those things to put in the back of them. Oh, obviously you've come across it, but I just hadn't come across it. I always used new old stock AC, and Bosch points and that, and I'd never come across it. But apparently up until a certain year, they used to do all that. So it was that was one of these pull your hair out moments. And a quick primary and secondary test actually worked it out. But the points weren't sparking. I just couldn't work out why.
Another one what I've had is years ago on one of my cars, on my EK, which had the 179 motor in it, a brand new set of points, and the wire was partially broken. That's the little black wire. And at certain times, the car would run perfectly, and like you'd give it a bootful and then it would stop. And because it would start pulling on the wire, and then it would stop, and you'd start it up again, and then take off hard, and it would stop again. But anyway, I worked that one out in the end. But that was quite interesting, though.
Well, it's funny how these little things can get you. My mate was a mechanic he was a fantastic mechanic, and he had a condenser that'd work and then not work, or something like that. And it was another problem like that too. And he just said, I feel like I've never worked on a car before. These silly little
that's
things,
right.
but you need to have these faults to actually gain your experience, don't you?
Yeah. Well, what I've got at home here is I was lucky enough to pick up a coil tester. So what I can do is run a coil, and I can put it through all the paces at different RPMs and check it out before I put it in the car, which I can do 6 volt or 12 volt. And then the other thing what I've got is a condenser tester, which I also, because normally when I restore a car, a lot of times I just go to my box of condensers, look up the right number. Oh yeah, that's all right. And I test it. And I might have picked that up at a swap meet or something. and I knew it was the right one, but you don't know if it's okay or not. And then you just check it out, and then you get to a stage where you've thrown out half a dozen, then you've got a whole stack of good ones. So, but I have loaned that coil tester to a couple of club members over the years that have had coil problems, and it's really good to see how the coil's working.
Oh, that's fantastic. I've never heard that that normally it's just you replace it. I didn't know you could actually get it tested, but that's
Yeah,
that'd be very handy
handy.
because a lot of I used to do all those Monaro engine parts and that, and all those original number distributors, coils. People go nuts over them, and they're worth a lot of money if they got the right number. So testing one's always the go if you're trying to resell one. You know what I mean?
Yeah, exactly.
Oh, yeah, all good. That's my story anyway.
Yeah, no, that's great. Thanks, James, for sharing that.
No problem.
Any more questions?
Just a comment, getting back to, I think it was Frank's question about why do we need a separate ignition switch? Can't just run the wire from the coil?
Yep.
Because otherwise your ignition power would be backfeeding to your solenoid on your starter.
Ah, yes, yeah, you're right. Yes, exactly. Yep. Yep. Any more questions?
Thanks, there's the penny drop.
Yeah, well, I didn't look at it that way, Frank. I just know that you can't have that wire, one wire. You have to have the extra part on the switch to do that. And especially when you've got older cars, like the 37 Dodge, if I wanted to run a ballast resistor ignition system, what I'd have to do to make that work. But yeah, but I'm just authentic. I just like to have everything how it came out of the workshop, because I reckon it's the fun when it does break down of sorting it out.
There's cleared it up, otherwise your bloody starter would be running all the time.
Yeah, yeah, exactly.
8 volts will be trying to anyway.
Yeah.
Yeah, yeah.
I used to work with Des at Chadstone Toyota, and he was the head fault finder there. There's nothing he could never fix, so he's definitely a guru.
Yeah.
They
no, very good.
People after him.
I've not met Des before. Are you from Des and Gray? Is that?
Sorry?
No, he's not.
No.
No.
Okay.
No.
So Des, when did you start your apprenticeship?
I started late, about 1988.
Oh, right, okay. Yeah.
How long did you work at Chatty Toyota, Des? When did you start before me?
Yeah, I started there in 88 and I worked there till 2000.
Okay. Well, I was there from 98 to 2006. So I thought you were there more than a couple of years working with me anyway. I thought it was longer than that.
No, Rick started, remember Rick, he started, I think, 87, I started 88.
Wow, there you go. Okay. Yeah, I mean, I know they could hardly replace you once you left because you could fix anything. You were a real thinker, but all there was oil changes there at Chatty Toyota. So they missed you when you left.
Yeah, well.
You're a very modest man, Des. You always have been.
Yeah, well, when they pay bonuses for people that don't change coolant because they get the service done quicker, make more money, they get a pat on the back.
That's exactly right. Oh, good to see you, Des. Anyway.
Yeah, James.
That's it.
Any more questions?
Bruce, what was the solid state ignition system? That was what Chrysler used, or they called it that in the 70s, late 70s, with the ignition, electronic ignition.
Yeah, well, it must have been some sort of ballast resistance. Yeah, I'm not 100% sure on Chrysler in those years. I never had an interest on those cars, but maybe somebody else can fill us in on that.
Yeah, solid state's just another name for transistor.
That's what they were quite proud of, the way they had electronic ignition when others didn't, from sort of VJ onwards, and other than a lot of the 70s stuff had it with the CMs and all the rest. But Centauro had electronic ignition.
Yeah.
Well, of course, they had electronic ignition much earlier on some of the engines, even the 59 DeSoto. They came out with an electronic ignition. I'm talking... it was electronic ignition, but they had to scrap it after that they'd been running a few months because they just didn't last. They had paper capacitors in them, and they used to fail, and started to give the DeSotos their reputation for not being the most reliable vehicle out there. And they all got binned, and people were replacing them with ignitions from the other models or earlier models. So they date back a long way, but luckily technology has improved a hell of a lot, and the reliability now is obviously pretty good.
That was actually 58, the electric ejector they called it.
Yeah, yeah.
The pretty cool system. There's one bloke in America, Thomas White from Whitehall Restorations. He spent 600 hours redoing the whole wiring board to make it work with modern capacitors, and got the whole system going. That's the only one in the world that goes. And the car sold for $500,000, but that's got one working on it. So it was made by Bendix, I think.
That rings a bell.
Bendix electric ejector, they called it. But yeah, pretty cool.
Mm.
Yeah, so there's one of those bits of info.
That Bendix thing, that was the fuel injection, I thought.
Yeah, it was fuel injection. Yeah,
It was fuel injection, was it? Sorry.
It was the fuel injection. Yeah. And what I heard is they replaced them and put the dual carbs on for them.
They did, yeah. But most of them got thrown in the bin. But this Thomas White's been in the 58 DeSotos for years, and he managed to save one and from an old dealership shut down. And he reaped 600 hours just on the board. That's a lot of hours.
Yeah.
You'd have to be a bit of a guru to do that. It's not something I'd be doing, but even for anyone who wants to put, like, say, Valiants or Chryslers or anything back to original, you can now buy those birdcage alternators, or you have for a while, the Power Master ones. I put them on to be original, and they're 75 amps, so that you can run a lot higher. You can have stereos and anything, and they're made with the original tooling, but they're 75 amp, and they make like a solid state voltage reg with all the proper markings on the outside. So I put all that stuff on. You don't have to change any wiring or anything, and keeps me happy because I'm not technically minded like that. I just like to bolt something new on and off I go,
Yeah.
But then it looks totally original. So they're a great thing. Those save me on all the cars, because once you put modern headlights in and all that, the original 30 amp alternators are just junk.
Yeah, that's right.
But I love the look of them. So that's the best of both worlds on that one.
Yeah, that's good. Yeah.
Yeah. Anyway.
Any other questions?
It's like we're ready to finish then, Bruce. So thanks for that.
Yeah.
And
hopefully everybody enjoyed that. And,
yeah, fantastic. Well done.
And we look forward to the next topic, which, as you said, you're aiming to do SU carbies.
Yeah.
Which is pretty relevant for some of our models. Not mine, but that's fine.
I don't know what Chrysler had one. Maybe a updraft carburetor, sort of similar. Maybe I should put that in too. But anyway, and the thing is, if anybody's got any knowledge that they want me to do a presentation on, or they might be a guru and they want me to present it, I'm quite happy to do that also. So, yeah.
All right. Well, thanks for that, Bruce. I'll stop the recording now, and thank you very much.
No worries. Yeah.
Thanks,
See you all soon.
Thanks, Bruce.